Think about the physical wires running under your street right now. We have laid down millions of miles of fiber optic cables, capable of moving terabytes of data across oceans in a fraction of a second. That massive capacity extends straight to the phone in your pocket. We've blanketed continents with high-speed nodes, promising instant data transfer from anywhere on Earth. Despite this hardware, you spend a frustrating amount of your day clicking a link, staring at a blank screen, waiting for a wheel to spin. The pipes themselves are wider and faster than they have ever been. The slowdown isn't happening in the cables, it's happening in the underlying architecture of the websites we're trying to load. Strangely enough, if we look back at the early internet, the structural speed was often superior. Even with dial-up connections, the base architecture of a 90s website was incredibly efficient. Those early pages were just static HTML files. They required zero processing on the server. When you clicked a link, the server simply grabbed a pre-made text file and handed it directly to your browser. Static delivery is the champion of speed, but it has a flaw for creators. If you wanted to fix a typo or add a new article, a developer had to manually rewrite and upload the raw code for the entire page. To solve that flexibility problem, the industry shifted. We moved away from static files and embraced dynamic, database-driven content management systems like WordPress, allowing anyone to publish content instantly without touching code. But that convenience introduced a massive hidden mechanical cost. Today, when you visit a typical WordPress site, the page doesn't actually exist until the exact moment you click the link. The server scrambles. It queries a database for text, fetches layouts and images, and stitches them together. This assembly creates measurable delay. Users often wait 10 seconds for a WordPress page to resolve, as the server struggles to build every page from scratch concurrently. We prioritized the creator's ability to update sites easily, but we hampered the user's experience with a performance tax that slows everything down. Modern engineering focuses on a specific redundancy. If a page's content hasn't changed since yesterday, there is no reason for the server to rebuild it from scratch for every new visitor today. This led to the static edge network. The idea is to build a page perfectly just once, and then place optimized static copies on servers stationed right next to the user, ready to be delivered. We don't have to abandon the dynamic databases that make publishing easy. We just need an automated translator that sits between the dynamic WordPress backend and that static edge. Platforms like Nimbika provide that exact bridge. This workflow diagram shows how it functions. It takes a standard WordPress site, runs it through an AI optimization engine, and automatically outputs a static experience. You don't need to rebuild the site. You simply start by generating a secure API key and downloading the connection plugin directly from the optimization dashboard. You then paste that key into your existing WordPress backend. From that moment on, every time you publish, the plugin automatically syncs your dynamic content and pushes it to the static edge. Eliminating server rendering time results in a first contentful paint of 0.6 seconds and a performance score of 100 on desktop. This delivery method scales to mobile devices as well, reaching a performance score of 97 and a 2.1-second largest contentful paint. By serving static files, we bypass the processing limitations of mobile CPUs. Third-party tests corroborate these results. This report shows a grade A of 99%, with an LCP of 674 milliseconds, and a near-zero cumulative layout shift, indicating the page stays stable while it loads. The historical trade-off is broken. A website can act fully dynamic for the person creating it, while remaining perfectly static for the person visiting it. Stripping the database away from the live user also provides a security benefit. A hacker cannot breach a database that isn't connected to the public-facing site. The commercial advantages follow as well. Hosting costs decline because static files require minimal computing power, and search engines reward the 16x speed increase, shifting from that 10-second baseline to a sub-second response, with higher rankings. The future of web architecture relies on decoupling how we manage our content from how we serve it. We haven't just reverted to the simple files of the 90s. We've merged legacy speed with modern flexibility, bringing the architectural pendulum to its resting place.